Hello everyone, welcome to MathsTuber. So today we are going to start with the new chapter sets. So first of all, let us learn what a set is. So the question is, what is a set? And the answer for this is, a set is a well-defined collection of distinct objects. Right. So for example, if I give you an example here, let us consider a collection of all the vowels. So all the vowels in the English alphabets are A, E, I, O, U, right? So this is a collection of all the vowels, and it is well defined because everyone, if you ask anyone to form a collection of all the vowels, he or she will make the same collection. So it will be a set. Then second is, uh, suppose you are asked to do a collection of the natural numbers less than 10. So it will be 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is also a set, right? Because the natural number less than 10 will always be 1 to 9. But if someone asks you that uh, top 10 batsmen in the world, then everyone will have a different choice for the batsmen in cricket, right? So this collection will not be a set, as it contains as if you ask anyone about top 10 batsmen, then he or she will have different choices for that, right? So this is not a well defined collection of distinct players in the world, so that's why it is not a set, right? So now a set is always represented by curly bracket. A set is represented by these bracket, curly bracket, right? So for example, if you want a set of vowels, then you will have to write it like this: A, E, I, O, U, and inside the curly bracket, right? Similarly, others also, set of natural numbers will be 1, 2, 3, 4, and so on, right? And so you have to enclose the all the elements of the set in these curly bracket, then only you can say that it is a set. Otherwise it will be a collection only. Now let's talk about the representation of sets. So representation of sets. So the first representation is roster form. Roster form, or you can say tabular form also, the one which we have studied so far. For example, this A, E, I, O, U. This one is known as a roster form only, or the tabular form, right? Because it is having all the elements in it, right? And the second one is called the set builder form. This is called the set builder form, which represents a set in general form. For example, if you want to write the set of all vowels in set builder form, then you will have to write x such that x is a vowel, right? And if you want to write natural numbers less than 10 in set builder form, then x such that x is a natural number less than 10. So you have to define this x here, right? So this x such that x will always be common in every set builder form, and then you have to define this x. So is a natural number less than 10. This will be your set builder form. Now there are a few symbols which we have to learn in this. So the symbols are, first is this one, which means belongs to. If an element belongs to a certain set, then we can use this symbol. Then similarly, this symbol, and if we cross it, then it means that does not belongs to. It means does not belongs to. Third is this symbol. So it means there exist. If something exists in a set or in an interval, then you can write this, there exist. And fourth is, if we cross it, then there does not exist. There does not exist. Right? So these are the symbols which we are going to use in this chapter. And there are a lot more symbols which we are going to use. We will study them one by one. So I have till now told you about the representation of sets in two forms, roster form and set builder form. So suppose you want to example is, suppose you want to form a set of letters in the word Mississippi, right? So you will write A equal to, first of all we will write it in the roster form. So M will be here, then comma I, comma S, comma I, comma P. These will be the letters of the word, and we will not repeat the letters in the roster form here. Repetition of letters is not allowed, or repetition of anything is not allowed in the sets. If there are repetitions, then you have to avoid that. And if you want to write the same set in set builder form, then x such that x is a letter of the word Mississippi. This will be the set builder form for this set, right? So now let's learn a few more symbols. N represents the set of natural numbers. We all know that natural numbers start from 1 until infinity. Similarly, whole numbers, which includes 0 as well. So set of all whole numbers are represented by W. Then Z is for integers, set of integers. Then we have Q, which is the set of rational numbers. Then we have T, or I, which represents the set of all irrational numbers. And last is R, which represents the set of all real numbers, right? And if it is written that this one Z positive in the superscript, then it means that set of positive integers. Similarly, we can write it for R positive, which means positive real numbers, or anyone here like Q positive or Q negative. Z negative represents the set of all negative integers, right? So these are the commonly used symbols for the set of numbers, different set of numbers. So let us do a few questions based on this. But before moving to the question, let us first do an example on the basis of these symbols which we have done. So suppose A is a set which contains 1, 2, 3, 4, then A comma B, a set is there, then 5, 6, like that. So there will be a few parts here whether these elements belong to a set or not, this set or not. So if someone asks you that one will belong to A or not, so if one is an element here, so yes, it will belong to this set. Then if suppose someone asks you that A comma B belongs to A or not, then you can say that A and B are not the exactly elements of these. The whole set AB is the whole set AB here belongs to the set A, but this will not belong to A, right? Similarly, if someone asks you that 3 comma 4 comma 5 comma 6, a set of this belongs to A or not, so it does not belong to A, because it is already a set here, and a set does not belong to a pre-existing set. If there was no curly bracket here, then these elements will belong to the given set, right? So this is how we have to use these symbols, belongs to and does not belong to, right? So now let's come to the exercise of these questions, what we have studied so far. So these are the questions which are given in the CBSE support material. So this is exercise number 3.1. So we have to, in the first question, we have to tell which of the following are the sets and which are not. So the first is the collection of most talented authors of India. So as I told you that it is not fixed that for every person, the most talented authors can be different, because we all have different choices. So it will not be a set. So we will write here not a set. Then the collection of all months of a year beginning with letter M. So there are a few months only which are beginning with letter M. For example, March, May. Yeah, that's it. And therefore it will be a set because everyone will answer the same thing. Then collection of all integers from -2 to 20. Yes, it is also a set because there are a few integers between 2 and -2 and 20, which will be same for all the persons. Then the collection of all even natural numbers. Yes, this is also true. This will also be a set because even natural numbers are 2, 4, 6, 8, 10, and so on for everyone. The collection of best tennis players in the world, it's not a set because every person has a different choice, has a different favorite players in the world. So it will not be a definite or you can say well-defined collection of players, and therefore it is not a set. Then in the second question, we have to write it in the set builder form. So how to write these in the set builder form? We have to first recognize the pattern which is going on in this set. So you can see that 4, 8, 12, 16 and 20. All these numbers are the multiples of 4, right? And till 5. So 4 ones are 4, 2s are 8, 4 threes are 12, 4 fours are 16, 4 fives are 20. So how will you write it in the set builder form? It will be x such that x will be equal to 4n, where n belongs to natural numbers and n is between 1 to 5. So this will be your set builder form. So it will be a multiple of 4. So we have written 4n here, and n belongs to natural number definitely, because these are the multiples of 1, 2, 3, 4 and 5. And then we have to define the limit of n also. So it will be from 1 to n, 1 to 5, and 1 and 5 are included. So we have put this equal to sign here along with this less than signs, right? Then after that, p is 2, 3, 5, 7, 11, 13, 17, 19. So all these numbers are actually prime numbers. You can see 2 is a prime number, then 3, then 5, then 7, then 11, 13, 17, 19, and so on. So how will we write it here is x such that x is a prime number, right? Similarly, we can recognize this also. C is a set which is the collection of all the consonants. A, E, I, O, U are missing from here, and all other alphabets are here. So we can write it as x such that x is a consonant, right? And D 1 minus 1 comma 1. So 1 comma minus 1 are actually if we write x square equal to 1 here, then the root of this x square will be x, and the root of 1 will be plus and minus 1, right? So according to this, uh, these two numbers are the solutions of x square equal to 1. So this will be x such that x square equal to x such that x such that x is a solution of the equation x square minus 1 equal to 0. So this will be your answer, right? So this is how we can convert the numbers into set builder form, means the roster form into set builder form. Now let's move to the next. Similarly, this is the fifth part. We have to convert it into roster set builder form, sorry. So it will be x such that x. Now these are 41, 43 and 47, and all these numbers are prime numbers between 40 and 50, right? So x such that x is a prime number between 40 and 50. So you have to just uh, recognize these numbers, that what is the relation and how can we write it. Now the next is 1 comma 1 by 2 comma 1 by 3. If we clearly see here, x such that x is equal to 1 upon 1 plus n, and where n belongs to whole numbers. So if you will put 0 here, first of all, 0 is the first whole number. So if you will put 0 here, it will be 1 upon 1, which is the first term. Then if you put 1 here, it will be 1 upon 2, which is the second term, and so on. It will go on forever till infinity, right? Similarly, this will be x such that x 1, 1 upon 4, 1 upon 9. You can see that all the denominators here are the squares of the natural numbers, right? So we can write it as x such that x is equal to 1 upon n square, where n belongs to natural numbers. We don't have the square of 0 here in the denominator, so we will write down n belongs to n because all the natural number squares are given. So this will be the answer for these questions where we have to convert them into set builder form. Now the questions in the question number third, these sets are given in set builder form and we have to convert them into roster form. So x such that x, first is a is equal to x such that x is a whole number less than 5. So whole number less than 5, whole number starts from 0 and these will be 0, 1, 2, 3, 4, right? We don't have to include 5 here because we are asked less than 5 numbers only. Then b is x such that x is an integer. So x lies between -4 and 6. 6 is included, but -4 is not. So -3, -2, -1, 0, 1, 2, 3, 4, 5, and 6. These are the numbers which will be included in the given set. Then C is, we have to find the set of all the letters of the word follow. So F, comma O, comma L. Now L is repeated here, so we don't have to write it again. O is again repeated, so we don't have to write it again. So W will be there. So this is the set of all the letters of the word follow, right? Now the next one is x such that x is a 2-digit number such that the sum of the digit is 6. So all the 2-digit numbers whose sum is 6. So 1 is 15, then 24, then 33, then 42, then 51, and the last is 60 because 6 plus 0 also becomes 6, right? So the sum of the digits of all these 2-digit numbers are 6. Now fifth part is E. So E is set of all the letters of the word arithmetic. So A, R, I, T, then H, then M, E, then T, I are repeated, so they will not be written here. And then last is C. So this will be the set of all the letters of the word arithmetic here, right? So this is how we have to convert them into roster form. Now let's move to the let's move to the fourth question now. Here we have to match these according to their correct matching. 1, 2, 3, 6, 12. All these numbers are the factors of 12. So the first one will be matched with C. Then 2, 3, and 5. These are all prime numbers less than 6, you can say, or prime numbers less than 7, you can say. So this will be marked with E option. Then Tuesday and Thursday, these are the days begins with T. So this will be A. And 0, 3, 8, and 15. 0, 3, 8, and 15. Uh, this will be n square minus 1, n belongs to n less than equal to 4. So if you will put 4 here, oh sorry, 1 here, because n belongs to n, so it will start with 1. 1 square minus 1 becomes 0, right? So, and so on, it will go on like that. And 1, which is the smallest natural number, this is the D part. So this is how you can match these. Now we have to fill this using these symbol belong to or does not belong to. So this is the set 1, 2, 3, 4, 5, and B is another set. X is a factor of 4. So we can write B as, we can write it in the uh, say roster form 1, 2, and 4. All these numbers are the factor, and C is also given here. So 4 belongs to A. Yes, it belongs to. So we will put the symbol here. 3 belongs to B. No, it does not belongs to B. 9 belongs to C. Yes, it belongs to C because it is there in C. 1 belongs to B. Yes, it belongs to B. So it will be belongs to. Right. So this is how we can do these questions. So in the next part of sets, we will be doing the other things, right? Till then, see you. Bye bye. Thank you.